is blind sight. Okay, blind sight. Blind sight is a phenomenon, is a condition in which some people, they claim that they are blind, but they can actually see things. So they claim they are blind, which means in their conscious track, they don't experience anything. They don't actually experience vision. But if you ask them to say, go across a hall with obstacles in it, with tables and chairs and stuff, they can actually avoid them and then go across, like the picture said, like this figure shows here. So this person claims that he is blind, he cannot see anything. But if you put some obstacles on the hallway and ask him to go through, he can actually avoid them and go through. Okay, which is quite weird. So this tells us that our mind has two tracks. So this person maybe has some brain damage, maybe has some strokes and stuff, lesion, right? Remember, brain damage is called lesion in his brain, so that his conscious track is blocked. His conscious track is damaged. So the information that enters into his eyes and enters into his visual cortex does not give him a conscious representation of the world, but he can still, well, quote unquote, see things. He can still know where the objects are, and he knows to avoid them. Okay, which is quite awesome, right? Okay. There's another experiment that's not in the book, but I think is pretty phenomenal. I can explain to you. They've done experiments with blindsight people. Okay, again, they claim that they are blind, but the experimenter took them to a computer screen. Okay, so this is a computer screen, and on the screen, so there were over trials, there's a cursor, there's something, let's say a mark on any corner of the screen. Okay, so the mark could appear in the top left corner, or it could appear in the bottom left corner, or top right, or bottom right. Okay, so in one of the corners there's a mark on the screen, and the researcher is just asking these people to basically guess where this mark is. Because if you ask them to tell me where the mark is, and they will think you're crazy, right? Because I'm blind. How can I possibly know where the mark is? Okay, so the researchers, they just said, okay, you just need to guess. Okay, so while they feel very weird, but still they guessed. Okay, and surprisingly, if they are really blind, then they're really guessing, then the rate of correction is only like 25%. Okay, right? Only in 1 out of 4 trials they can guess it right. Correct? If they're truly blind. But for the blind side people, they can get it right in over 95% of the trials. Okay, so basically in every trial, they know where the mark is, but still they claim that they are blind. Okay, so again, knowing where objects are is unconscious. Okay, and even though you might not have a conscious representation of the world, of the vision, because of some brain damage and stuff, you can still know where the object is. Okay, so the dual processing, dual track mind. Okay, two-track mind. Okay, so there were 2 tracks here. One is the visual perception track. This gives you the conscious representation of the world, and also visual action track. It guides your movements. It knows where the objects are. Okay, if that makes sense. Next, parallel processing and sequential processing. So sequential processing is like math problems. When you try to process a math problem or anything like any task that requires logical reasoning and stuff, you have to get the outcome step by step, right? So that's what it means by sequential processing. So you use it for solving problems. Parallel processing is just it takes care of your routine business. Like just like I said, when you look at something, you know its color and its size, and you know every aspect of it immediately because you process it parallel. The parallel means that you process many aspects simultaneously. Okay, you process many aspects of a problem in the same time. An example of parallel process is driving. Okay, so you see when people are driving, they are not actually analyzing what should I do or whatever. They're more or less autopiloting, right? When they get familiar to driving. So in the beginning, when you just start to learn driving, okay, you are engaging in sequential processing. You have to think, okay, if I'm gonna turn right, I'm gonna turn my wheel, I'm gonna turn on my indicator, I'm gonna look at where the roads are, whatever, right? But once you get more and more familiar, more and more skillful at driving, then the whole process becomes parallel. Okay, you immediately process everything and you just drive like, like automatically. Okay, so while driving, you can still do something else once you get familiar. Okay, so gradually, easy tasks can go from sequential processing to parallel processing. If you think about math, it also has an example. Say when you're young, you're learning like addition and subtraction. So say like 13 minus 8. When you're young, you have to maybe process it and count it and take some time, right? But once you get say at your guys' ages, you process 13 minus 8 automatically. So it becomes parallel processing. When you see it, you know the answer. You immediately know the answer. Okay, so easy tasks can go from the sequential processing to parallel processing with practice. Okay, so yeah, just these two, especially the dual track mind, like conscious, unconscious processing, parallel, sequential So parallel processing is similar to unconscious processing, and sequential processing requires conscious processing, right? They are pairs, okay? Pairs of concepts. So these can be harder than other concepts, and yeah, and they will be tested, okay? So next, genetics, heritability and environment, nature versus nurture, right? So these are very easy to understand. Chromosome, DNA, genes, well, they won't be tested, just some very foundational stuff. Okay, very foundational stuff. I think you should have known them in your biology class. Okay, in your science class, science 10, right? Science 10 has already covered this part. Okay, and then we have twins. For twin studies, we explained it before. Remember, in intelligence unit, we explained how we can use use monozygotic twins and dizygotic twins to do twin studies, so that we can know for a specific property of people how much heredity and environment contribute to the phenotype or to the manifestation of a trait. Okay, remember, monozygotic twins raised apart, right? Monozygotic twins, they have 100% the same genetic makeup, but if they were raised apart, then they have different environments, right? So if we compare between monozygotic twins who are raised apart, then we can see what genes and environment contribute to trait. Okay. And dizygotic twins. So twin study will be explained before. So separated twins, we study them to understand the interaction of nature and nurture. Okay, see if it can make sense. This, okay? So whenever you see twin studies in exam, it's basically just identical twins reared apart, identical twins raised apart, okay? Yeah, relatives, biological, adoptive. We explained that before. Biological parents, adoptive parents, and stuff, right? So I'm gonna skip it. Okay, heritability. Remember the heritability estimates? We also talk about it in intelligence chapter, right? So heritability estimate is a number between 0 and 1. And again, in our midterm, we also explain it. It's an estimate, first of all, okay? And every study gives you different estimate. So it's not an accurate estimate, it's just a ballpark estimate. It's just a rough estimate, okay? And it's an estimate of, well, to be specific, the variation among people, like the variation among people that you can see can be explained by, say, genetics by how many percent. So this is, again, related to statistics. So just remember that heritability estimate does not apply to individuals. Does not apply to individuals. For any given individual, how much have you got from your parents? It's really unique for everyone. Okay. All right. So for gene environment interaction, this is also something we've explained in intelligence chapter. So something like intelligence, your genes will determine basically a range of IQ for you. Say that your genes determines that you are smart, you're bright, then maybe it determines your range of IQ to be, say, 120 to 130, okay? And say that you have a dumb gene, a gene determines that you are dumb, maybe you are like between 70 to 80, okay? And the environment determines a specific value within the range that was determined by genes. Okay, say that you are your family is wealthy, you live in you were raised in an enriched environment. You've got good education, you've got many toys to play with, you've got Lego and stuff. Then you are at the higher end of the range that was determined by the gene. Okay, so if you have a good gene and you have good environment, then you are here. Maybe you're 130, you have 130 IQ. If you have good genes, but you were raised in a poor family, you don't have proper education, you don't have enough stimulation while you were a kid, then maybe you are situated in the lower end of the range. So maybe 120 and stuff. Does that make sense? Okay, if you have a dumber gene, say your gene determines that your IQ is between 70 to 80, then again, if your environment is poor, is impoverished, then maybe your IQ is 70. And if your environment is enriched, your environment is really good, maybe you're at 80. Okay, so that's basically for every other trait, how the environment and gene interact. Okay, so another example could be the gene that determines your weight or your height. If you think about it, it should make perfect sense. So if you're say your gene determines that you're a tall person, then it really depends on your environment to see which part you fall at. So let's say your gene determines that your height will be between, say, 180 to 200 centimeters. Okay. Then if you're well nutritioned and if you are exposed to more growth hormones than others, if you play basketball like Clavon, then maybe you can grow to 196. Okay. If you have poor nutrition, you don't play basketball, you lift weights such that your height is suppressed, then maybe you're just at 181. Okay. Gene determines the range and the environment determines the specific value. If your gene determines that you are a short person, maybe your gene says you are 150 between 165. And again, it depends on nutrition and your habits and a lot of things, a lot of environmental factors, right? If all the environmental factors determines that promotes your growth, promotes your height, then maybe you're 163. And if you sleep late, you're turning late, you have bad nutrition and stuff, if all the environmental factors determines that you thwarts your growth, then maybe you're 151. that make sense? So genes for weight, for height, for intelligence, they determines a range for you, and your environment determines where exactly you are. Okay. Any question about this gene environment interactions? Okay, good. So I'm gonna skip this. This has epigenetics is a branch of genetic study that has attracted more and more attention recently. Okay, so what epigenetics says is that there were factors that could alter your genetic expression. So what genetic expression means? Do you guys know what this mean by genetic expression? Okay, now, have you ever heard of a saying that we share 99% gene as chimpanzees? Like 99, 98% of genes are the same among people and chimpanzees. Have you ever wondered how does the 1% difference in gene make so much difference between us and chimpanzees? Well, actually, they can't. Okay, it's not a 1% gene difference between us and chimpanzees that make us so different from chimpanzees. It's actually a genetic expression. Okay, so this could be a little bit hard. Let's go a little bit back to DNA part. Okay, so okay, it goes too much back. Okay, anyway, so I believe in your science class you have learned how genes, like what is the role of a gene? Do you guys remember in your science class? Why do we say gene determines our trait? Like how exactly does gene determine our trait? Because gene guides a process. What process? You guys remember? No? Gene guides protein synthesis. Remember? Gene tells you how to make proteins in your science 10, in your biology 11. You guys remember? Okay. Well, the basic building block of our body is protein, right? In every cell is made of, well, numerous proteins. Okay. So proteins make up our body. So that's why, and genes guide how we make proteins. So that's why gene can determine our trait. Make sense? Okay. Now, in humans, we have over 26,000 genes, but not every one of them guides protein synthesis. So actually, only about 20% of the genes guide protein synthesis, and the other 80%, they're what we call dormant genes. Dormant genes, they're sleeping. Okay, they don't actually, they are not actually involved in protein synthesis. They do nothing. Okay, so the a part of the gene, the 20% of the gene that actually guides protein synthesis, that actually are involved in protein synthesis, we say they express themselves. When we say a gene expresses itself, we mean that the gene is involved in protein synthesis. Okay, when the DNA opens up, the gene actually comes out and form the proteins. Does that make sense? That's what genetic expression means. A gene is being expressed means that the gene is involved in the process of making proteins. Okay, when the gene is not expressed, it means that the gene is dormant, it's sleeping. It doesn't really affect you. Okay, so we see that only about 1/5 of our entire genetic makeup is involved in our genetic expression. So you are not actually determined by 100% of a gene. All of your traits, how you look like, your IQ, your height, your weight, all these stuff are only determined by the genes that are expressing themselves. Does that make sense? So that's why even though we have basically 99% the same genes as chimpanzees, and actually if you compare across people, if you compare me between Torres, between Clavon, we actually share about 99.9% genes. Okay, we have the same because we are the same race. We are males and we have a lot of same genes, okay? But the reason that we are so different from one another is because we have different genetic expressions. And the genetic expressions is also heritable. Okay, so you got your genetic expression from our parents. I got my genetic expression from my parents. It is the genetic expression that matters, not genes themselves. Does that make sense now? Okay, any question about this? Okay, so the reason why we have so much differences between chimpanzees is because of genetic expressions. Okay, yeah. All right. What epigenetics, what this branch of genetic study does, is that they study how environmental factors can alter your genetic expression. In other words, the environments can also change your gene. It doesn't change the gene per se. It doesn't really change your genetic makeup because that's your DNA. That's not changeable, right? That's not alterable. It just changes the way some genes are expressed or some genes are not expressed. Okay, make sense? That's what epigenetic studies. So it has been, so this is really recent. 10 years ago, this was still in doubt. Okay, but during this decade, more and more studies reveal that epigenetics is true. Okay, and now we have actually found some epigenetic food, some food that you ingest that can actually make you more healthy, make you healthier, not because they can or make you live longer. Okay, but not because they can change your genes. They are only changing your genetic expression. Okay, so for example, epigenetic food, the most famous examples are broccoli and kale. Okay, but if you want to know the full list, you can always Google it. So you on Google, you can Google epigenetic food. They are very healthy food. Epigenetic foods. See, the most famous ones are broccoli and cabbage and kale. So broccoli and kale. Yeah, and there were a few others. So yeah. So yeah, so if you wanna live longer and become healthier, and you also want your children to become, and also your grandchildren to become healthier, to live longer, you better eat more broccoli and kale. Okay, that makes sense? Epigenetics. Okay. So not only food, but also activities, what you do, what kind of environment you're living in, your personal habits, all of these can change your genetic expression. So for example, if you put more effort in studying, if you are more diligent, more assiduous, yeah, it can actually turn on some of your good genes, and it can actually be heritable into your children. Okay, so kids will be more, will put in more effort, will be more diligent, which means that they are more likely to be successful. Okay, your personal habits. So that's why. So that's another reason added to why we should put more effort into studying, and this kind of stuff. Okay. Yeah, and you also your nutrition. Yeah, so there are a lot of things that might alter your epigenetic markers. For epigenetic marks, this one you don't have to understand. It's just some markers that turn on or turn off your genetic expression. There were methyl groups and stuff, but they won't be tested. So just read it through, and yeah, not very important. But yeah, if it's in a test, then basically just testing on the idea of epigenetics. Okay, the idea that you can change genetic expression is called epigenetics. Okay. Next module, evolutionary psychology. Basically, across all the units, whenever we can get to evolutionary psychology, I was mentioning it, right? So hopefully you can understand the evolutionary perspective throughout the book. Okay, not only just from this module, but to understand many aspects or phenomena of human beings. Okay, so before if you guys remember in classical conditioning, We mentioned the biological restraints, biological preparedness to learn vomiting with taste aversion with poisoning, right? Those are also evolutionary perspective. Okay, so we will explain this throughout our journey. Okay, so yeah, but here just understanding some very basic evolutionary ideas. I think you guys know what natural selection is. Okay, right? So natural selection, the nature, quote unquote, selects individuals who are more adaptive, right? Who can adapt to the environment better. The reason why this helps you pass on your genes is, well, if you live longer, you can have more offspring, right? If you have more offspring, and again, your offspring will inherit your traits, right? So say that there's a certain trait that allows you to live longer. It allows you to survive better, right? Then that means you're going to live longer. That means you're going to have more offspring. And your offspring will inherit your traits. And they also going to, since they have the same traits as you have, they're going to also live longer. They're also going to have more offsprings. And again, their offsprings are going to have the same trait. And gradually, in the whole population of the species, your trait becomes your trait. Since it promotes survival, it becomes more and more prevalent. And in the end, the whole species have this trait, because the individual members who don't have this trait are extinct, right? They die. Does that make sense? Okay, so that's the whole idea. That's a basic idea of evolutionary perspective, the Charles Darwin's natural selection, right? Okay. So yeah, so these are some explanations. I'm gonna skip them. It explains a lot. There was just some examples. You can have a look. A very good explanation here I want to talk about is human sexuality. So we know that men and women, they have a lot of differences in choosing partners, choosing their sexual partners, right? So we all know that men are, you could say, more sexually active than women. Like uh, they actively initiate more sex. They masturbate more. And even if you look at animals like dogs and stuff, male dogs masturbate much more than female dogs. Okay, so even in animals, males initiate more sex. Males are more sexually active, and the reason for that is also lies in evolution. Uh, the reason why women are very selective in sexual partners, but males are not. Like you see, males they tend to have more sexual partners than females do, right? They even pay prostitutes to have sex, right? The reason for this is that well, first of all, sex is rewarding to both genders. That's without doubt. Okay, both genders, they love sex, they love orgasms. Okay, mm, and again, the reason why we love orgasms, why we love sex, is also evolutionary. Okay, because if there were certain members in our species who don't like sex at all, then they have much lower reproductive chances than us, right? If they don't like sex, they have less offspring. So gradually that trait will will become extinct. Okay, and since everyone loves sex, but female, they have more costs. They bear more costs in sexual activity, because after sexual activity is childbearing, right? Childbearing comes in a lot more cost for women than men, because for men, we actually don't need to bear any children. We just need to have sex and they have children, right? The cost of childbearing is very, very low for males. Very low. Almost nothing. Okay. Just one sexual activity. There we go. Okay. But for females, they're gonna spend 9 months, right? Suffering from all childbearing experiences, to give child. And after child after they give birth, they have to nurture them, they have to nurse them, they have to give milk and stuff, right? So they have a lot more cost than men do. So that's why they are very selective in in sexual partners, because they only want to have sex with people who they trust, who they believe that they are good fathers. Okay, they can provide them with enough resources, not only them but also their children, because they spend a lot of time and effort in giving children, right? So women want to make sure that their sexual partners or their potential sexual partners can provide them with enough resources for themselves and also for their children, so that they, after if they are conceived, they have support. Okay, so they're much more selective. So they want to choose men who are more resourceful and who are faithful. Okay, because it doesn't really matter if you're resourceful, even if you're the wealthiest person in the world. If you are not faithful, you don't, after you have kid with one woman and just dump her, it's meaningless to that woman, right? So women wants to marry with men who are faithful and who are resourceful. Okay, make sense? And for men, we just want to have more sex, because sex is rewarding, and we don't have any consequence. Okay, so yeah, there have been a lot of studies that probe into male and female sexuality, and all the studies reveal that males are more lenient in choosing sexual partners. Okay, they are they are more welcoming to sex. Okay, mating preferences, and also what male prefers. So we just explained what female prefers in a marriage, in a sexual relationship, right? Resourceful and faithful and loyal, right? What males prefer in a sexual relationship is well, in terms of evolution, it's basically just childbearing abilities, because the end product, the end of having sex the end of having sex is to have babies, right? So males are more focused on childbearing abilities of women. So that's why in general you see males prefer younger female, because younger female are more fertile than older females, right? And it's also true in animals. Okay, even animals older, males are they prefer younger females more. Okay, because younger females are more fertile. Okay, and also if you look at men they like women who are who have curvature statue, I mean, big bosoms, and and then big bottoms and stuff, right? And the reason for this is, again, so for women, if their hips are bigger, hip to waist ratio is bigger, then that means it's easier for them to give birth. Okay, and unknowingly to all of the men, we are evolutionarily, or we are genetically determined or predisposed to like women who have bigger hips, and also bigger bosoms, because bigger bosom, they can nurse their children better. Okay, so that's why you see basically most of the men, basically every man, they like heterosexual man, they like bigger hips and bigger bosoms and stuff, and also prettier face, because prettier faces mean that they are like the women are healthier. Okay, yeah. So mating preferences, younger women, beautiful women, and sexual women, right? So we say they're sexual, they are sensual, yeah, because they can give birth better. Okay, so that's evolutionary psychology, and yeah, we will see more and more examples in when we explain other phenomena of human beings. So that's unit 3, and we're gonna go to unit 4. For the questions on the book, do you guys have any questions here? After you've done this, you compare it to the answer key. Okay, you guys have the answer key? I think for yes, you should have the answer key now. Okay, so if you have any question about any of the questions in the book, let me know. We can explain in class. Okay. All right. So unit 4. I suppose you guys have done at least maybe a few modules already. Okay, good. So I'm gonna also just cover the important, like the hard part to understand. Okay. So sensation and perception. The difference between sensation and perception, sometimes it can be confusing, so I want to explain it. So sensation is basically what you feel, what information you receive in your sensory organs, okay? And perception is how you make sense of it. So for example, when your eyes are exposed to lights, and lights become neural impulses and go into your brain, that's your sensation. And we'll make sense of it. We look at this, say, mouse here. I know this is a mouse. I know it's black and red. I know the logo says Logi and whatever, right? It's a wireless mouse, whatever. Okay, I'm making interpretation of my sensation. I'm interpreting what I'm seeing. Okay, so my interpretation is called sensation. What I'm seeing, the information, the light I received in my eyes is my sensation. Okay, make sense? Sensory perception. Okay, so in this unit, we're gonna study our senses, our vision, our audition, and touch, and a lot of different things. We're gonna first study the level of sensation, like how exactly does light, for example, transmit into our brain as in a form of neural impulses, and also how our brain makes sense of those neural impulses. Okay, so there were two processing that we have just seen. Sensation is more about bottom-up processing. So bottom here means like the bottom sensory organs. It could be your eyes, it could be your ears, it could be your skin, which is the tactile sensation receptors, right? So there were receptors in your sensory organs that pick up signals from the outside world and transmits information into our brain, right? So bottom refers to those organs and up refers to our brain. So bottom up, lights going to your eyes go to your brain, bottom up. Okay, make sense? Now, of course, our perception stems from sensation, stems from bottom up processing, right? If you keep your eyes closed, you don't have vision. Okay, that's very easy to understand. But the opposite of it is much harder to understand. It's a top-down processing. So top, again, it means your brain, and down means your consciousness. Okay, so top-down processing means that our perception are not entirely dependent on our sensation. Our brain plays a role in it. Okay, what you see is not what you receive in your eyes. Okay, your expectations, your experience, your brain plays a part in it. So, for example, here we just explain it. To make sense of something, you need perception, right? You need your brain. So imagine that a person who has never seen a mouse, okay, say a person in African tribes, okay, they're Aboriginal people, they've never seen a computer before, they don't know what a mouse is, right? So when they see this mouse, they won't recognize it as a mouse. They will just think it's a very peculiar object, right? So your brain plays a part in it, okay? The reason I know it's a mouse is because of our past experience, and also because I'm sitting in front of a computer, I have expectations to see a mouse. Okay, if I see a mouse in a butcher shop, then maybe I might mistake it as something else. next to a pig. So it's really weird, right? So your expectations can affect your perceptions. Okay. Another example, if you think about hallucinations, people hallucinate. Hallucinations means they see things, they see images, they hear things, they hear voices out of nothing. They see images out of nothing, right? Hallucinations. So why do they have to commit hallucinations? Well, their brains give rise to those hallucinations, right? So you might consciously experience something that are not even there. So hallucinations are not driven by bottom-up processing, they are driven by top-down processing. Okay, so there are many, many other examples. Yeah, okay. Yeah, this is also an example of a bottom-up and top-down processing. So if you see a rose here, if you see a flower here, then that's top-down processing. Because other than that, because instead of a flower, this is actually, you see two people hugging each other, right? Two people are here, these are their feet, and then they have their shoes here and stuff, right? And even their stockings here. So if our perception is entirely bottom up, you should actually see two people cuddling here instead of a flower. But and two people here and some rose petals. There were a few rose petals here and stems here, stem and stalk. Okay, but if you just look at it, the first impression should be just a flower, right? A rose. So yeah, again, that's top-down processing involved in here. Okay. Any question? No? Okay, so next, selective attention. Well, that's very easy to understand, but make sure you understand this cocktail party phenomenon or cocktail party effect. So, but it's very easy to understand, right? It means that it refers to an effect that if you are in a cocktail party where a lot of people are communicating, a lot of people are talking, so imagine that you are in the middle of a cocktail party, everyone is talking, right? So you have a lot of streams of information going on, but still you can somehow filter the irrelevant information out and perform a dialogue with your partner, right? Say you two go to a cocktail party, you two can talk to each other, even though a lot of people are talking to, well, one another right beside you. You can actually hear what they're talking about, but you can somehow filter the information out, filter those irrelevant information out, and just pick up the information that's relevant to you. Okay, so that's the cocktail party effect that manifests our selective attention. So the property that our attention is selective, we can selectively pay attention to something. Okay, make sense? Yeah, it's not hard to understand. Yeah, these are just some experiments. If you have any question during your reading, let me know. If you don't have, I'm gonna skip these because these are very easy. Okay, attentional blindness. There's an experiment here. Make sure you understand, right? Because people are paying attention, even if there's one woman walking across the screen, they never notice it. Okay, so you can also call it selective inattention, or inattentional blindness, and yeah, change blindness is also one form of inattentional blindness. Yeah, inattentional blindness and change blindness will definitely be tested. Okay, just one question, it's just going to test you what it is. Okay, make sure you understand the concept. If you don't understand, let me know. Choice blindness and change deafness. Okay. Okay, if that all makes sense, I'm gonna just talk about the next one. Okay. So the next concept, transduction. This one, I believe, it could be difficult to understand. So it's not difficult, but a lot of people they just overlook it. Okay. So transduction, you don't actually you can you don't really use this word in your daily life, right? It's a specifically academic term, okay, academical term. It means to convert one form of energy to a form that our brain can use to neural impulses. The form of energy that our brain can use is action potential, electricity, right? So just neural impulses. So for example, for vision, we have to convert from light, which is a form of energy, right? It's a wave, into neural impulses. That process is called transduction. Okay, so later on when we look at the structure of the eyes, we will, I will tell you, retina, if you have done your reading, retina, and specifically rods and cones, those, photoreceptors are the site of transduction for vision. Okay. So, the next part is psychophysics. So psychophysics is a field of study that studies how physical stimuli affect our mind. Okay, because quite literally, psycho is mind, and physics it just means the physical world, a physical stimuli. Okay, so how the physical stimuli can have an impact in our mind. Okay, basically how we perceive, how our mind perceives physical energies. Okay. All right. So the first question when we think about say vision and audition is probably the question of how intense should the sound or the light be for us to perceive it, right? So this is the absolute threshold. Now, I'm not sure if you have noticed the detail here. The absolute threshold is the intensity of a stimulus at which we can perceive the stimulus 50% of the time. 50%. So for example, if we are doing an experiment of absolute threshold on, say, audition, I'm gonna put this subject into a room for testing, right? I'm gonna put a earphone on her, and then I'm gonna play her some, auditory stimuli, right? Auditory stimuli, maybe just a tone of different intensity. So we start with the lowest tone, say, the intensity of the tone, the intensity of sound is loudness, right? Loudness, and loudness is measured in decibels, if you know, right? Decibels. So we can start with maybe 1 decibel, 2 decibel, and the person probably will say that they couldn't hear it. And then we gradually go to maybe 10 decibel. Maybe at 10 decibel, the person says she can hear it 1 time out of 10 times. Then that's only 10%, right? So we have to play the sound louder, maybe go to 15 decibels. Now the third person may say they can hear the sound 3 times out of 10 trials, but that's only 30%, right? So we gradually increase the intensity of sound, the loudness of sound, until an intensity, a level of intensity, such that a person could perceive the sound 50% of the time. And that's the absolute threshold, okay? If there's any question about absolute threshold, you have to mention 50%. This is very, very important, okay? Make a note here, please. In multiple choice questions, we will test on this. If it is free response questions, you have to mention 50% to show that you understood the concept. Not 100%, okay? 50% will do the trick. Okay, so if that makes sense, we're going to talk about signal detection theory. So for signal detection theory, if you think about this experiment, there's a fatal flaw to this experiment, which is that as the experimenter, I'm playing a sound every time, right? What if this subject may be under some psychological suggestions because she know that every time there's a sound, right? There's a sound present. So she might just say, okay, I hear the sound, I hear the sound. She might just say, I heard the sound, I heard the sound every time, right? So this is a major problem to this kind of to this experimental setup. Make sense, right? She might just say she heard the sound every time. Okay, so to avoid this, we can just alter the experiment a little bit. We alter it such that as the experimenter, I don't play the sound every time. Sometimes I play the sound, and sometimes I don't. Okay, and I let the subject know. So as a subject, I told the subject, okay, so there are a few trials. So some trials I'm gonna play a sound, and some trials I don't play a sound. So sometimes maybe you don't hear a sound, and that's correct actually. Okay, so you need to be faithful. You tell me whether or not you detect a sound. Okay, so in this way, I can bypass the problem where the subject is primed to answer yes, right? The subject might be, because if you play sound every time, she might just say she heard a sound every time, okay? So that's what happens in signal detection theory. So now you're gonna make a note because in the book, it doesn't have this chart. And I believe that using a chart can explain it pretty well, okay? So here we have stimulus, and here we have decision, right? Decision. So the stimulus, say the sound or light, it can be either present or not present, right? Present or absent. There could be a stimulus, and there could be an absence of stimulus. Okay, and the subject has to decide whether or not he or she detects the stimulus, right? So he or she might say, yes, I heard the sound, or no, I didn't hear the sound. Okay, so that means we have 4 scenarios here. Okay, in the first scenario, if there's a sound and they say that they heard a sound, then we call this a hit. And should make sense. It hits. You hit target, right? And which is, by the way, a correct response, right? Correct response. Okay. Now, if the stimulus is absent and the subject says he or she detects the sound, then that's wrong, right? Because there's no sound. How could you hear a sound? So that's wrong. We say it's a false alarm, which, by the way, is a false decision. Okay, make sense? A false result. And I believe the two words should speak for themselves, right? False alarm. There's no if you change stimulus, say to danger, there's no danger, and you believe there's a danger, you sound the alarm. False alarm, right? Okay. In the third condition, in the third scenario, there's a stimulus, there's a sound, but the subject decided that there's no sound. So that's what we call a miss, because the subject, misses the sound, right? Which is, by the way, again, a false result, okay, wrong result, a wrong decision. And in the end, if there's no sound and the subject decides that there's no sound, so that's a correct decision, right? So we call it a correct rejection. They've rejected the result correctly, okay, which is, by the way, a correct answer, correct decision. Okay, does that make sense? In the book, it only mentioned hit and a false alarm. So I'm just gonna put in fill in the missing parts, okay? So you know the whole story of the signal detection theory. of course, the signal detection theory is not this easy. There's more to it, but in AP, we only need to know what the 4 conditions are, and in every condition, is it a correct response or is it not? Okay, any question about this chart? Okay, now make sure you remember the 4 different results, okay, 4 different outcomes. Okay, yeah, if that makes sense, stimuli that are below the absolute threshold, we can say that they are not detectable, right? They are not perceivable, right? Okay, we cannot perceive those stimuli. So we call them subliminal stimuli. And subliminal, I believe this word should make sense, right? Because sub means below, right? And liminal just means limit. So it literally means below the limit, below the absolute threshold. Okay. All right. For subliminal messages, subliminal stimuli, can they influence our perception and sensation and stuff? So, we can look at this experiment, okay? So subliminal sensation. So an example of subliminal sensation in terms of like subliminal visual stimulus is an image that appears so short that we couldn't even see it. So for example, if I present you with an image which only lasts for 20 milliseconds, okay? An image that only appears 20 milliseconds. It is so short, it only appeared for such a short time that you couldn't even see it, okay? So for example, if you're sitting in front of a computer, you're looking at a blank screen, and on the screen, I show you kittens, or I show you a werewolf, or I show anything else. If I only show you that stimulus for 20 seconds, you won't be able to see it, although they did appear. Okay, so we say those are subliminal stimuli. Okay, so can subliminal stimuli affect your decision making, affect your mind? So before this, let's look at a very famous experiment in the history, okay, in the psychological history. So it was back into 1980s, like 1981, and they've done an experiment like this. So 2 psychologists, they go to a cinema, okay, and movie theater, okay, so they're playing movies, and on a movie screen, they show viewers this message. So eat popcorn, drink Coke. Eat popcorn, drink Coke, nothing else. Okay, they show this on the screen of a movie theater, okay, but only again for 20 milliseconds, okay, so that even if they've showed it, they've inserted this image in the middle of the movie, no one really realized it, okay. This has never been into anyone's conscious awareness. No one claims that they've seen it, okay, because it's subliminal. They just watch the movie as usual. They didn't notice, like the audience didn't notice any differences. Does that make sense? Okay. They just want to see if this subliminal message could persuade people to eat more popcorn and drink more Coke. All right. So initially, they they present this image, in the movie, on the movie screen, many times during a movie. Okay, many times, and then after a few days, they just compared the sales of popcorn and Coke, and compared the sales in these few days to the past, right? And they found that the sales of popcorn and Coke did rise. It rose up, okay, by like 30%. And they published their experiment. And this was a resounding finding, because if you think about it, if I just play some subliminal message to you, you don't even know that you see it, and it can actually make you buy. If you can actually make you eat more popcorn and drink more Coke, and that's very threatening, right? And that means if on TV we can just show messages to people and increase their consumer behavior, right? And make them buy stuff that they don't even need. And more threateningly, we can even put messages such as rise up to your country, or maybe support terrorism. We can show these now fearful messages on TVs, and then make people bad, right? So this was a really elicited a heated debate across the US. Okay. And also many psychologists really doubted the conclusion, because subliminal messages can persuade people into doing things. It just sound outlandish. Okay, so there were so many more psychologists later did a similar experiment, and they yield different findings. They didn't find the original findings. Okay, and and after about 10 years, it was they investigate the whole matter, and found out that in the original study, the two scientists, they actually fabricated the data. Okay, they actually presented false data, artificial data into the public to the public. Okay, make sense? So the experiment was fabricated. The experiment was a lie. Okay, so actually, so we don't need to worry about it now. Subliminal messages cannot alter your, say, consumer behavior, or make you or alter your decisions. Okay, but with that being said, we can still use subliminal message to prime people to do something. So for example, if you look at this experiment, in this experiment, we present subjects with different photos of people. Okay, so these are different portraits of people. And then they just need to rate their ratings of them, say, just based on how they look like. Okay, they just need to rate maybe from 0 to 10. Okay, if you think this guy is handsome, is very handsome, you rate him a 7, 8, or 9. If you think this guy is hideous, you rate him maybe 1 or 2, something like this. Okay, so you can rate them around, and then and on the back of the screen, similar to that movie study, we can flash images of cute kittens, or we can flash an image of a werewolf, again, for 20 milliseconds across the screen. So again, when they were rating the people, okay, they were not aware of the images that were shown to them. But still, portraits that were flashed with cute kittens received more favorable ratings from people, okay, from participants. And portraits of people who were paired with werewolves received unfavorable ratings from participants. Okay, does that make sense? So these subliminal messages, they can actually affect how participants judge judge how favorable or how these people look like. Okay, if you flash them with kittens, they believe that they are prettier or more handsome, and if you flash with werewolves, they start to like them less.
Wait, so is this like
What's that?
actually true?
Yeah, it is actually true. It's an actual experiment.
You said
And
a lie or something like that before.
the lie was this experiment. If you do eat popcorn, drink Coke, that was a lie. It doesn't work. It didn't work. So subliminal messages cannot persuade you into making, say, cannot alter your purchasing behavior. It cannot make you buy something more. It cannot make you become a terrorist, that kind of thing. Okay, but it can still affect your ratings of these images. Okay, so it can alter your consciousness just a little bit, but not to the extent that you can make a full-blown decision to do something. Okay, so this is actually true, but the other one is not. It cannot make you buy more things, but can make you feel that someone is more favorable. That's just it. Okay. Yeah. So, Clement, that makes sense. So you see, on the other side, subliminal persuasion didn't work. So if you present subliminal stimuli, again, stimuli that they cannot see or hear, if you present to them, say, I'm thin, or cigarette smoke tastes bad, if you try to present these messages subliminally, again, by audio and video, well, we don't have any powerful or enduring influence on behavior. See, no powerful or enduring influence on behavior. So basically, the conclusion is that subliminal persuasion is rather impossible. Okay, if you want to persuade someone you're doing something subliminally, that's not possible. Okay, but you might subliminally change your perception or sensation or just favorability of something, some stimulus. Okay, and this process we call it priming. Okay, so priming, we prime people, meaning that we are making them ready to do something. In this case, we use kittens and werewolves, even if they're subliminal, we are using them to prime people to make them, by priming people, we mean we are making them ready or more predisposed to like certain images or dislike certain images. Okay, so prime as a verb, it also means like to make something ready. I'm not sure if you guys know that. So for cars, you don't need to prime the engine because we use cars every day, right? Cars are very advanced. But for planes, for boats, since planes and boats, you don't start the engine every day, right? And the design of the boat engine or of a flight engine is in such a way that if you don't use it for, say, a day or two, the fuel that enters into the engine actually comes out of the engine. So if you want to start a flight engine after a few days of rest, then you have to prime it, what we say, prime it. So by priming it, it's basically just you step on a gas pedal, okay? So that you can pump the fuel into the engine and then start it. Okay, that's what we say, prime the engine. So it means basically get the engine ready to be started. Okay, so that's what we meant by priming here. Get something ready, get something predisposed to something. Okay, anyway, that's just a subliminal message. I believe that's hard to understand. So, and then another threshold is the difference threshold. Okay, so the difference threshold is the minimal amount of change that you can notice. So if you look at the other name of it, it should make sense. The other name is called, just noticeable difference, or JND. So difference threshold refers to, well, the just noticeable difference, the smallest difference that you can notice. Now, notice that this JND is not a fixed amount, but rather a proportion of the stimuli. So if you think about it, it should make sense. For example, if I give you maybe a coin and 2 coins, can you feel the difference of the weight? I believe you do, right? 1 coin to 2 coins, maybe 1 coin to 3 coins. Even though 1 coin to 3 coins, maybe the difference of weight is only, say, 20 grams, but you can still feel the difference, right? But what about, say, I give you a big watermelon and a watermelon with extra 2 coins? Can you feel the difference of the weight now? You can't, right? So with the intensity of the stimulus going up, you need more difference to detect the difference. Okay. Another example, if you are in a quiet environment, very quiet environment, then a slight noise, just very slight noise, you can notice it, right? Because the environment is very quiet. If you are in a very loud environment, say in a busy street corner, now it has to be a big noise for you to pay attention to it, right? If you only a small, there's only a small noise, if there's only a whisper, you couldn't really notice it. Okay, so the just noticeable difference is a proportion to the size of the stimulus. To be specific, the proportion is decided or measured by this guy, Weber. Okay, he's a German, so we say Weber is the Weber. So Weber's law. So he did a lot of experiments trying to determine this proportion. So yeah, so he actually gave us the proportion of basically every stimulus. So there's always a minimum percentage in different stimulus. Okay, so we call it Weber's law. So Weber's law is very frequently tested, but it's very easy. Okay, so Weber's law just states that two stimuli have to differ by a percentage or by a proportion, rather than by a constant amount, so that people can notice the difference. Okay, so say two objects must differ in weight by 2%. Okay, so if you have 100 grams, the other one must be at least 102 grams in order for you to feel the difference. Or if 1 kilo, it has to be 1 kilo and 20 grams. 10 kilo has to be at the end. And if one object is 10 kilos, then the other object has to be at least 10 kilos and 200 grams in order for you to feel the difference. Okay, makes sense? Differ by 2%. That's what it means. So that's what Weber's law states. Okay. Okay, next part, sensory adaptation. So sensory adaptation is very similar to habituation. Okay, see if you guys have any question for the materials before. No questions, I'm gonna continue, okay? So sensory adaptation is similar to habituation, that you have a diminished neural activity or diminished sensitivity as a consequence of constant stimulation. So before we explained that, for example, when you're wearing clothes, it's just constant stimulation, right? Your clothes is constantly stimulating your skin. And then because of a constant stimulation, you basically stop noticing them. Okay, very similar to that, basically the same. Okay, but the problem is that say that if you are staring at an image, okay, you are staring at this picture. If sensory adaptation is correct, you should see part of the image missing. Why? Because if you're staring at it, then this is a constant stimulation to your eye. It doesn't change and you don't change, right? If you're just staring at it. So part of it should be missing, because your sensitivity of or your perception of the image should diminish. Okay, it really should be, some part of it being blank, maybe this part being blank or that part being blank. Okay, but actually you don't feel it, right? Why? And that's because we later found out that our eye is jumpy, what we say saccades. So the word, if you want to know, is this word saccade. What saccade means that what saccade means is that your eyes basically scans across an image every moment. Okay, the frequency of saccades is about 3 hertz, so 3 times per second. Unknowingly to you, even if you are trying to look at a single, let's say a cross here, let me put a cross here. If you try to stare at this cross and without changing your position, without changing your eyes, without moving, you are unable to do so. Okay, because unknowingly to you, unconscious to you, your eyes are scanning everywhere, maybe scanning from here to here to here to here, 3 times per second. Okay, so that's why when you are staring at an image, you don't actually experience sensory adaptation and the whole image is not missing. Okay, but another experiment proves that sensory adaptation is true. In this experiment, we put an apparatus here, and this apparatus can track your pupil, okay, can track where you look at. Okay, so even if your eyes are scanning the environment 3 times a second, unknowingly to you, it can still track it. Okay, so that the images that you see, the images that say this head, this face, the images that you see is always constant across time. Okay, because even if your eyes are scanning, if your eyes are jumping, this apparatus can track it, okay, and always present to your eyes this stable image. Okay, in this case, we actually see sensory adaptation, in people. Okay, so these subjects, they start to see part of the image is missing. You see, okay, for triangle, part of the triangles is missing. For this one, HB, part of it is missing because of sensory adaptation. Does that make sense to you guys? Yeah. Without these apparatus, even if you're staring at an image, your eyes are still moving. Okay, you can control it. But yeah, if you use an apparatus to track it, like to make it stable, then the image will start to have parts missing due to sensory adaptation. Okay, there were other adaptations, but the sensory adaptation is the most important. The other, emotion adaptation. This is, we rarely tested. You can have a look. It's not hard to understand. So I'm gonna skip it. And yeah, I'm trying to go to the next module, perceptual set. It's just a mental predisposition to perceive something, perceptual set. So we gain perceptual set through experience and so through expectations. So first of all, so for example, this is an example. Okay, this is it's a quite famous picture. I'm not sure if you guys have seen it before, but this ambiguous image could be seen as a young lady here. I'm not sure if you see if you see this as a face, right? Okay, this is the hair, this is the eyelash. You see eyelash and nose, and this is the face, right? And this is the neck, okay? And this is the ear. Okay, you can see basically the half of the face of a young lady, okay? Or you can see as a grandma, right? Okay, you will see this as the eyes, and the nose is here, okay? And this is the mouth, okay? So you can see it as a young grandma, as either a young lady or grandma. Okay, it's kind of classic. Yeah, okay. Now, so if you present this picture to people, basically half of them will say they see a lady at first, and then the other half will say they see a grandma first. Okay, but of course, if you give them enough time, they can see both. But the first impression is either the young lady or the grandma. Okay, for people half and half. Okay, but if you present them something else prior to this, you will have a surprisingly different result. Okay, so here on the left side to this image, this image is unambiguously a young lady. Okay, because you see, this is a young lady. You don't see the mouth here. You see, there's no mouth here. The mouth is missing. Okay, so if you present people this image, this is obviously just a young lady with no grandma here. Okay, so if you present people this image first, and then you present them with a middle image, then basically every one of them will say they see a young lady, because the previous experience here has given them a perceptual set, okay, so that they can only see a lady in the middle image. They spend a lot more longer time to see there's a grandma, okay? And similarly, if you show them the image to the right first, you see this image is unambiguously a grandma, because you see the mouth, you see the nose, you see the eyes, and there's no eyelash. You see eyelash and nose is missing, right? Here you should have eyelash and nose, but you don't see this in the image on the right. So this is unambiguously grandma. If you show this to people, then every one of them will say they see a grandma. Okay, and then if you show these to people first, and then you show them the middle picture, they will spend a lot more longer time to see there's a young lady. Every one of them will see a grandma in the middle picture as well. Because again, if you show them the right picture first, you've given them a perceptual set. Okay, does that make sense? Okay, so this is how perceptual set can alter your perception. The perceptual set comes from your past experience. You see a grandma, you see a grandma in the middle. You see a young lady, you will see a young lady in the middle. Okay, and you could spend a lot more time and effort in spotting the other part. Okay, spotting the other women.
Are there like any examples of this in like real life? Like aside from these like pictures and stuff?
Like perceptual set. Imagine a kid who hasn't seen cats before, but he has only seen dogs before. Okay, if so a kid who hasn't seen dogs or cats, then the first time they see dogs, and their parents will tell them this is a dog, right? And the kid will remember this is dog. And later on they see a cat, they probably most likely they will say it is a dog. And that's also because of a perceptual set. So the past experience tells them, a little animal with four legs, with hair, hairy animal, on the ground with a tail. That's a dog. Okay, and when they see a cat, they believe it's a dog as well. But if you tell them it's a cat and tell them the differences, they can form a new perceptual set, and the new perceptual set could incorporate a cat in it. Okay, yeah. Another example, I had a pretty impressive example before. So when I just moved to Canada, I was going to university by myself, right? It was early in the morning. It was around like 7 o'clock in the morning. I was taking a bus to university. Okay, it was a foggy morning, so it has fog everywhere. At the time, I didn't know that I can see wolves. No, not wolves, like coyotes on the street. Okay, so in the fog, I see a coyote, but at the time, I didn't really expect I can see a coyote, so I thought it was a dog. Actually, no, I love dogs. So I also actually want to play with him. So I approached him. I tried to touch him, and then I found that that animal is different from regular dogs. It's just different. The eyes were greenish rather than dogs, and their tails were much larger than dogs and stuff. And I realized that's not a dog. That's a coyote. That's a wolf. Okay. That's also because of my perceptual set. Because in China, we don't get to see coyotes in the city, right? So in my perceptual set, I always expect a dog. No, anything like that on the street is a dog. That's my expectation. So I thought it was a dog, and I didn't realize it was a coyote. But after that time, I almost got bitten by it, but yeah, I scared it away. But after that time, every time I see something that looks like a dog on the street, I would suspect it's a coyote, and sometimes it's coyote, sometimes dog. That's how perceptual set can affect you. Okay, yeah, and this is another perceptual set. You see, if you look at only the column here, you will see the middle thing as a 13, but if you read it horizontally, you will see it as a B. So the same stimulus, this is the same visual stimulus, right? The same visual stimulus can well give you two different perceptions based on different perceptual set, because 12 and 14 gives you a set of seeing numbers, gives you an expectation of seeing numbers. So you see 13 in the middle. But if you see A and C, it gives you an expectation of seeing an alphabet, seeing a letter in the middle. So you see a B. Right? That makes sense? So perceptual set is basically just your experience and expectation is something that will change your perception, even if you have the same stimulus, even if you see the same stimulus. Okay, so yeah, this is also an example of top-down processing. Remember, top-down. Your brain has experiences, has expectations, and that might alter your perception. Another example, this is real life example. This is monster in Loch Ness. Loch Ness monster, you guys know this tale, right? It's a very famous tale, right? Loch Ness monster. When I was young, the Loch Ness monster hasn't been confirmed a lie, okay, like a false stuff, okay, a false thing. So when I was young, I read book about it. I was also fascinated by it, but a few years later, they've confirmed that there's no monster in Loch Ness. So if you have an expectation to see a monster in Loch Ness, then when you go to Loch Ness, there has been hundreds of witness reports of seeing a monster in Loch Ness. And the reason for that was simply because people expect to see a monster in Loch Ness. So they when they travel to Loch Ness, if there's anything suspicious, they report that they see a monster. Like this was one of the photographs they shot, and this photograph has been used by many newspapers and the media as the evidence of the monster in Loch Ness. Again, that's because of an expectation, because of a perceptual set. If you really study it, look at it without a perceptual set, you will see that this is not possible. This can't possibly be a monster, because if you look at the like the waves here, like the ripples here, the ripple is like circular, right? So it means it's something dropped in the water. If this is a monster, if this had been a monster would swim, right? If this had been a monster, it had swum over here. So the ripple should look like something like this, right? If something is swimming, the ducks, the ripple, okay, right? So yeah, later on when after we confirm that there's no monster in Loch Ness, then a lot of photographs that says there's a monster becomes clearly wrong. Okay, it doesn't really show a monster there. So perceptual set, okay. Perceptual set also exists in other situations like context, motivation, emotion. This part. So this part you can read it. There were a lot of evidence, a lot of experiments that are very interesting, but they won't be tested. So just some examples showing the power of perceptual set. Okay. This is a very powerful example, I believe. Okay, so just one last example before we go. If you look at this image, what is this thing? I believe both of you should see a window, right? You believe that it is a window, right? Okay. But if you show this to East African tribe members, they actually believe that this is an object this woman is using her head to hold. Okay. Why? because in their culture, you see, if you ask East Africans, they actually believe that the woman was balancing a metal box or can on her head instead of a window. And that's because in our culture, we expect to see a window inside a room, and then there looks like a tree outside, right? And sky and stuff. It perfectly fits our expectation, so we believe there's a window. But for East Africans, they don't live in modern structure, right? They live in their huts, and their huts, they don't actually have windows. They don't have windows near houses, okay? And also, it is their convention or tradition to carry stuff on their head, okay? Like Indians, okay? So that's why they believe this is a metal box. Again, you see how perceptual set works there? This perceptual set was formed by culture and by context. Okay, and there were many more perceptual sets that can be formed by, you see, the context or emotion, the emotion, and the motivation and stuff. Okay, so you guys can just read through. They are very easy to understand, and yeah, just basically understand the idea of perceptual set. The examples here won't be tested as specific examples. You just need to understand the idea. Okay, so that if there's a multiple choice question, it gives you some scenarios. Which options you should choose. Okay, and then next ESP, it won't be tested, so you can read through it. It's very easy to understand. Basically, there's so-called supernatural stuff, but all of them are just fakes. Okay? They're all fake people now. So whatever. So you can read through. None of them is true. Okay, none of them exists. So just read through and skip them. Okay, they won't be tested. Yeah, and that's module 17, and yeah, and let's call it to an end today. And for your homework, I want you guys to finish your reading for unit 4, entire unit 4, okay, module 18, and all the way till the end of unit 4. If you have extra time, please do some reading in the next unit too. Okay.